Testing, testing, 1, 2. Testing, testing, 1, 2.
Let's go ahead and skip 4.2.2 since we're not going to be using the nitrogen bottle.
All right. Well, I'm Ben. I'm the outreach manager here for CPP Rocket Powered Lander, and we're going to do some interviews. Use the mic. So, oh yeah, wait first. First of all, what is your name, major, and what's your role on the team?
I'm Samuel Tonies. I am an aerospace major, and I'm the guidance, navigation, and controls sub-team lead.
Perfect. So, first of all, easy question, easy question. How did you sleep last night? Where did you sleep specifically? Were you camping, hotel?
I slept in the back of Yash, our avionics lead, the back of his car. We're looking at a good 4.5 hours of sleep, plenty enough for test day, as much as you can expect.
That sounds good. I know some of the other guys have a little less, so you're above average on that sleep probably, unfortunately. All right, so what have you been working on specifically for this Hotfire test?
A controller in order to control the thrust output of our rocket engine.
Nice, sounds good. All right, and then since you've been in RPL for a while, right? You would say? Well, what's your favorite memory being here in RPL?
I'm sure everyone's going to say the same thing, but definitely the last time we did our first successful static fire test. It's just, even though there were some hiccups, it's so amazing to see everyone's work finally come together and into this big giant inferno of rocket power.
That's awesome. And then for this Hotfire specifically, what would you say we are trying to achieve personally? And then what are you trying to achieve? It might be the same thing, but what are you trying to achieve?
I would say my personal goals and the team's goals are very closely aligned. So last time we did our static fire test, we did fire the engine, but we were unable to get accurate load cell data and know if we really throttled the thrust of the engine. So the big objective of this test is to control our thrust and satisfy the thrust curve that we're aiming to hit, which is 550 pounds max thrust, throttle down over 5 seconds, and then throttle back up.
Perfect. All right, you made it through all the serious, all the tough ones. Last one for you. What's your favorite ice cream flavor? Let's hear it.
Some people hate it, but my tried and true is the mint chip. I'm a mint chip defender.
Nice. I also enjoy a little bit of mint chip, so I'm with you on that boat. All right, well, it's been a pleasure interviewing you real quick. Thank you, and keep working hard, and let's have a good hot fire. Oh, my bad. All right, we got one more interview for now. So, as I said before, I'm Benjamin. I'm the outreach manager. And who do we have here?
I'm Harrison Bennett. I'm the structures and manufacturing lead here.
What's your major?
I'm studying aerospace engineering.
Perfect, perfect. All right, Harrison. First question, and you can hold the mic when I hand it to you. How did you sleep last night? Where did you sleep? How many hours you get? Let's hear the gist.
So I slept in the trunk of my car. It's an SUV, so it wasn't too bad. I got, I think, 3.5 hours, which all things considered is pretty good. I think top 15% here. So not too bad, really.
That's pretty good. Yeah, from what I've heard, definitely that might be on the high end, above average for sure. All right. What have you been working on specifically preparing and while we've been doing stuff today? What have you been doing working on for this hot fire test?
So for this hot fire test, me and my team were responsible for basically setting up the whole test stand, right? Getting the test structure up, integrating the engine onto it, making sure that it's all there, it's all stable, and that we're getting basically good readouts from the load cell. And, not too much has changed from our last test, just really improvements to our integration procedure, more practice, and some light modifications to basically make the system a little bit more stable because the stabilizers we had on the last test were a little bit lacking.
Perfect. That sounds good. All right, Harrison. You've been in RPL for a while, right? You would say a
3
decent
years.
amount. 3 years. All right, that's a decent amount of time. What would you say is your favorite memory being in RPL?
Oh man, I would say it would honestly be a toss-up between our first hot fire attempt and our second. Even though the second one we actually did get a successful burn and that was amazing, I think the first one is gonna hold a special place in my heart just from the amount of problems we had, how long it took, and just the struggle we went through to get out here, and just how much we really learned from it. Just I think just everything we went through for that makes it so much more special to me, even though we didn't get a successful burn.
Okay, that's perfect. That's a great answer. All right. What would you say? What is RPL, or what are you personally trying to achieve today in this hot fire test?
I'm trying to make sure the engine doesn't fly off, basically. Me personally, I want to see that the new stabilizers we're using is working and that we're not getting bad readouts from the test end or anything we have set up there, that it's all working as designed, and that we can kind of move on from here, me and my team, to further improve the system and be able to move on with our next tests and more design for the vehicle.
All right, perfect. All right, last question. Those were all the tough ones. Last one is, what is your favorite ice cream flavor?
I would say it'd be chocolate chip cookie dough with a close second of mint chip.
Oh, okay.
Close second.
Sam was saying how mint chip's not too popular, but I guess not.
The people who don't like it are just wrong.
True, I like it. Cookie dough's always good too. So
It is.
Yeah, can't complain. Those are good answers.
No.
All right, well, thank you very much, Harrison. It's been a pleasure, and yeah, keep working hard out there. One. All right, this is Outreach Manager Ben back with another interview, and here we have a very important guest. Would you like to introduce yourself?
Sure. I'm
You can hold it.
I'm the program manager right now, the test operations manager, Tim Batum.
Nice. So what's your major and what's your? I guess you already said your role, but say it again. What's your role?
Mechanical engineering major in my 4th year, and I am the program manager of the Rocket Powered Lander project.
Perfect, Tim. Great to have you here. All right, first question, easy question. How'd you sleep last night? How many hours you get? Where'd you sleep at? You know? Oh, really? The mic is on. Testing. 1 second.
They might just think like we're looking up, and we're like, why are they looking up?
Yeah, I'm not. I didn't do anything different. Let's see. All right, first question.
What do you mean?
They're capping. It's a chat.
Sorry.
Turn your volume up if you don't already. We're nice and loud. I can hear myself. All right.
Okay.
As I was saying, how'd you sleep last night?
Not great, but it was in an insulated truck, so I was warm and cozy, at least. I got 2 hours of sleep. That was okay.
Shoot. All right. I think you have the lowest of the 3 interviews so far. So you're bringing the average down, but that's okay. As you have a pretty important role, you should be getting the least amount of sleep. So yeah. You know, it's a big day, so less sleep, maybe not the better, but anyways, what have you been working on in preparation for this Hotfire test?
So, like, are we referring to the weeks before or the days
just
before?
A general overview of everything. Yeah.
Okay, well, this is the program manager perspective. So primarily we started, agenda setting back in the beginning of summer. And then after that, our design changes that we wanted to do. To do that, to finish that off, we did our internal design review at the end of summer, which was like August 29th. And we also, doubled that with the system requirements review for our lander design. So we were doing that and also the test configuration internal design review. After that design review, we were cemented into a design freeze, in which we set our goal to have a water flow simulation test, in which we proved that our system would work in a water flow situation, right? I believe there's some content out there that explains that. Anyways, so what was I on? So the water flow. After that, we did our test readiness review, where we presented a little bit about design, reiterating the stuff from the internal design, but primarily talking about all the verification testing we did. So in the weeks up until that test readiness review, we did load cell verification, we did throttle valve characterization, all sorts of jazz, and also did some last minute controls, chaos. So that was fun. And then after that, we did some logistics. So pretty much preparing whether people can sleep, eat, drink water, make sure that our operation is smooth, that sort of thing. And then, so then it was just a matter of getting here, and that was the whole, tweet in itself.
And now they can see what we're doing live. So there you go.
I don't think you wanted that long of an answer. But
Nah, it
that's
was
the answer I
perfect.
gave.
That's great. So I enjoyed it. Someone needs to give our whole spiel,
Okay.
So yeah, you've definitely been pretty busy, a lot on your plate. You've been in RPL for a while. How many years have you been in it?
I think I'm the longest, I think I'm the person that's been here the longest at 4 years. I think it's 3 years and 6 months right now. So.
All right. So you've been here for a while. What would you say is your favorite memory out of everything you've gone through here?
Oh, sorry.
Someone's dragging something.
Oh, sorry.
Favorite memory out of all the time you've been here.
Favorite memory. God, there's so many. I think the best thing yet has been the static fire test number 3. Number 2. Sorry, this is number 3. Seeing all the progress that we did come to fruition that time was probably the most satisfying and fun thing. But I will say static fire test number 1 was also incredibly fun. That was the first time we've ever gone out to FAR as a group, right? So this is the 3rd time we've ever been to FAR, right? I know, yeah. Some clubs they're here before, like this was like our very first time. So that's what really made it so satisfying, was that I was here for 2 years. We'd never gone to FAR. We were preparing. We were saying we were going to go to FAR. It just never happened. And then we finally, the things started to click into place. We were working really hard, and we made it happen. And that was probably the coolest event. And seeing that freaking sunrise or sunset, it was so blue, and it just lives in my head. And that was really, really cool.
That's awesome, Tim. That's awesome. Love to hear it. All right, let's see. A couple more questions, not too many. What are you personally trying to achieve here at the Hotfire Test? What do you want to see come to fruition today and tomorrow?
What do I want to see come to fruition, right? So I guess the answer I would, you would think I would give would be a successful test. However, I'd rather see people happy at this test. I'd rather see them, like stoked about what they did. So whether that means that we meet all of our goals or not, I think that's probably lower down on the list of my priorities. So, but like obviously my priorities are to keep people safe, that sort of thing, run the operation, right? But if I'm gonna say this is a successful mode, I'm gonna come back and feel good about myself. It's gonna be that people are feeling happy at the end of the day and are proud of what they did. So if I can enable that, then I've done a good job.
That's awesome. Great to hear. Great to hear. Last question. You got through all the tough ones. Are you a cat or a dog person, and why? Let's hear it.
Okay. I think I'm a dog person. I always love my dog, obviously, but my girlfriend has a cat, and they're very cute. So I would have came over to the cat side, but maybe I think I'm still more of a dog person.
Okay. So your girlfriend hasn't persuaded you yet? You're not going to give a nice answer? What if she's watching right now, and you just said that live?
Oh shit. Okay. Well, I still think dogs are better.
Ooh, all right. Double down on it. I like it. Well, it's been a pleasure, Tim. Thank you for interviewing.
Okay.
And yeah, get back out there, work hard, and yeah, we'll see you around. We'll definitely see you on the live stream. So yeah, thank you very much. All right, we got one more interview. Again, my name is Ben. I'm the outreach manager, and if your volume's not turned up, turn that stuff up so you can hear our beautiful voices. So, who do we have here? What's your role? What's your name? What's your major?
I'm Ezekiel. Most people know me by Zeke or Z. I am a Avionics member. So my lead is Yash, and we've been working on pretty much all the electronics that are going to be shown today, or I guess going to be used today, I should say. And if you couldn't guess, I'm an electrical engineer. So I've been dealing with the hardware mostly.
All right, nice to meet you. Nice to meet you. First question: how did you sleep last night? Where'd you sleep? How many hours you get?
I probably got a few hours less than most people. I was just amazed by the stars last night, so I stood up late with Nathan taking some pictures. But I slept pretty well considering. I was way warmer than I expected, so I think I got some good. I mean, our team pretty much had everything ready coming here, so I wasn't too nervous for us, and I work alongside a lot of smart, cool people that I know for a fact are going to get things done today.
Yeah, if you didn't know, we're in the middle of the desert right now, so it's super hot. But as soon as the lights go out, it's beautiful out, super dark, not a unnatural light out in the sky. So yeah, it's beautiful.
I know, it's crazy.
Yeah, exactly. So what have you been specifically working on in your avionics team, or just in general for this Hotfire test?
Well, in all honesty, I joined a little late, so so I didn't get too much opportunity to do too much. But like I said, I'm hardware, so I've been actually co-leading the design for the PCB that's going to be actuating all the pressure transducers and the solenoids and such. And we're essentially just focusing on data acquisition. So all the parts that went into that, I had to make sure that the PCB was up to code pretty much, and we had a few hiccups, so I had to make sure to also troubleshoot with Yash, and that took a minute, but as of now we have something that's pretty stable, and I'm excited to actually finally see it in use today.
All right. Perfect. That's great to hear. So you did say that you haven't been in RPL for a long time, right? Not too long. Do you have a favorite memory out of the short time you've been around here?
Yeah, I would say that more often than not, it's a new memory every other day because like we've been working. At one point, we worked 17 hours just on campus trying to get everything to finally work. We finally get it to work, and then we take 3 steps back. So the troubleshooting is always painful, but it's always rewarding. Other than that, I would say that last night was just awesome because we got to finally set up our the fruit of our labor under the beautiful night sky that I've never seen like fully. It was insane. I mean, at one point we could see the Milky Way. Did you get to see it last night? No. The Milky Way was pretty visible before the moon was just like really, 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 really bright, and then it just kind of drowned it out. But yeah, I got a glimpse.
Dang, that's crazy. I'm sad I missed out on that. Well, what would you say you are personally trying to achieve here, or what is your team trying to achieve here?
Yeah, like I said, we designed a PCB with the sole purpose of data acquisition. So we're trying to get the data, and then we let GNC handle the rest pretty much. We integrate with them obviously, so we work pretty closely side by side. Me personally, I'm just trying to get as much experience with the PCB design and microcontrollers, embedded languages. So far, programming's been a shaky point for me, so that's why I joined in the first place to see if I can pick up anything along the way. Our team, like I said, data acquisition and trying to feed that over to all the other teams, let them do what they need to do with it.
Nice, that's awesome. Not too many better places to get experience than right here, so that's perfect. All right, you made it through all the tough questions. Final question. You heard what Tim had to say. What are you, a cat or a dog person, and why?
For a long while, I would say both. I couldn't really pick. I love cats because you could always stay inside and just hang out with them. They were never too needy in terms of attention. Well, I guess some cats are, but you know what I mean. Dogs, I love dogs. They're always your best friend, loyal. They're always fun and cute, and they're always silly. No matter what kind of dog you have, they have a personality that just kind of mirrors their owners sometimes. But I think as I've grown older and lazier, I would say, I think I would kind of lean towards cats these days. Even though I do get overwhelmed with the fur. You know what I mean?
Yeah, of course, of course. All right, so on RPL so far, we got one dog person and one cat person. Is there anyone persuading you in this answer? Like maybe Tim might have a little persuasion. Any parents or family or girlfriend, boyfriend? I don't know. What are you saying?
Well, my girlfriend has always had at least a cat and a dog, so like it's always been tough. But um, I don't know. I think I've had more dogs in the past, so like it doesn't make sense that I lean towards cats. But I don't know. They're just easier to handle. Like.
Well, it's been a pleasure to interview you, and yeah, keep up the good work.
All right. Well, so Ben is taking a leave for a second. He's gonna go set up so we get some better angles. Not that our angles are bad. It's just we want to give you guys the best we can.
Yep. And we're probably going to be posting those on our Instagram after our hot fire. So take a peep at that.
Yes, yes. Please keep in contact with the organization or try and even get involved. Even we have entry-level programs, don't we?
Yeah, we do. We usually do in the fall, but we also do regular recruiting for other years. Pretty much any major we have, well, any STEM major, going from physics to mechanical engineering, aerospace, everything in the project. So keep an eye out for that for spring recruitment and again for the fall.
Yeah, and if you're STEM, like I said, like he said, there's a place for you. Even if you're a media consultant, or
Even if you're, we have business majors in the organization as well. Well, we have one, but that still counts. So.
Yeah. It's another way to get your resume, your experience up. Even
build up, yeah.
exactly, and it might seem out of the ordinary, out of the box, but whatever works, it's the same.
Yep, exactly. Also, if you do want to watch our better footage, our GoPro footage of our hot fire that will be happening in, I think, about 40 to 50 minutes. We will have it on our Instagram at CPP RPL. Ben, it's CPP. It's CPP dot. Okay, well, it's either CPP.RPL or CPP_RPL.
If you're a STEM major, you'll figure it out. Yeah. We trust you guys. We're just a little frazzled right now,
Everyone's on like 2 hours of sleep. Been working nonstop for the past 2 days. So,
Dude, yes. And
actually, honestly, a lot of us for the past 2 weeks. So,
dude, even a month maybe, because
maybe.
maybe the amount of work we've been putting into this is just like I'm so beyond proud of the team.
Yeah, I know. We've done a lot. We've come a long way. A lot of us have pulled through in tremendous ways, and we've gotten a lot done in a very short amount of time, and also a long amount of time.
Yeah, and not
Down, by the way.
one GoPro.
One GoPro's down. Sorry about that. We're gonna get that up and running as soon as we can.
Just technical difficulties. It always happens, but where are we right now? Can we talk about it?
Sure. We're at the propellant loading. Honestly, I am the mechanisms lead, so I can't really give you guys a good description on what the propellant loading entails. But I mean, you can tell from the video we're currently, well, if Ben moves his hand, we can see that they're moving our canopies that we had set up and move things out of the way because we're essentially loading our fuel to do our tests really soon. We are going to have our red crew team near our I-beam very soon, so they can do exactly that. I believe right now our structures and manufacturing lead and their members are just verifying that everything is set up well, that our feed system is integrated correctly, and all of our actuation systems are integrated correctly. And then once that happens, I think our red crew is just suiting up, and they are coming in. Oh, never mind. I just got word that they're loading in the nitrogen. That's probably what's happening. You know what? I probably should read the operations manual. That's probably.
I mean, it's important that we know our side of the operations manual just so that we get everything running right and correctly at a steady pace. So it's not always imperative or even a good idea to know it front to back when you're part of a sub team, just so we don't get confused or step on each other's toes or cross lines.
What happened? Exactly what happened just then.
Yeah. So we have a little behind the scenes manual behind right here so that he can reference it and give you guys a little bit more. But essentially that red team or this red code that we're on the cusp of it. We're on the cusp of actually testing. So stay tuned. I'm hoping you guys are enjoying so far. I mean, we put a lot of time and effort into this live stream. Definitely came second to testing, but I think that's just a testament as to how much we can do, considering how well and how good it's looking right now.
Yeah, I believe we just did our leak check for our feed system, and then we are going to depressurize really soon. And then once that's complete, which is a very, very long step, our red crew is going to approach, and then we're going to set up our GoPros like we were saying before, which is why Ben is gone. He's going to prepare for that, and then we're going to get our nitromethane filled with our tanks.
Yes. We're going to go set up the GoPros. In fact, that is where Ben and I are going right now, actually.
I'm just going to continue the
Go for it.
You know what? I don't really know how to turn off the mic, so I guess we're just going to keep talking until Ben and friends come back. All right. It overheated a little bit.
Maybe it's very hot right now.
Uh-oh, our GoPro might not work. That's a little
When I
sad.
come back, I'll fix that. Let's just go set up.
Okay.
In that case, how about we, you want to mute or you want to keep going?
Yeah, let's mute so that I can help them as well. All right, bye guys.
stream, and I was just like, oh, I guess I am on the stream now.
Well, it wouldn't be too far since you're the DAC operator. I mean, let us know what that entails.
I'm so serious, y'all. I press about, I think it's like, if you wanted to be really generous, it's 10 buttons.
10 buttons.
Because
No?
well, I'm being generous because it's like you gotta press up to go back to the previous command, then enter. Then I gotta press 1, 2, 3, not 4, and 8.
But 4 you can press.
I can press 4, it won't do anything. Yet. Yeah, true.
I've been working with Nathan. I gotta say he's been the most technical person I've met, and Yash is definitely a close second. They always got to make sure that everything's accurate, and that's good because honestly, it's what's keeping our deck from being from front. I guess. I mean, I would like to think that I I did a good enough job that
it shouldn't be fronting.
yeah,
You did your job.
I did my job. You guys did your job, and that's. I mean, you created the deck so that it was that easy.
No,
I mean,
Yash created this version of the deck.
I mean, you created the data acquisition, the GUI, the GUI.
We're not running that today, unfortunately.
Oh, okay, got it.
So basically,
Still in development though.
well, yeah. The thing about Avionics is that number one, we get our stuff done. Number
First
two,
and foremost.
we get our stuff done correctly.
Yeah.
If correctly is what somebody else told us. So if you told us to do something, we will do it to a T.
To a T.
Which is to a fault for everybody because sometimes, you don't necessarily know what things you want to be doing. You don't necessarily know like what things might change, all
Yeah.
those kinds of things.
I'm not sure I follow. Do you have an example?
Yeah, so a great example that we had to deal with today on site actually was we have a motor on our test stand that is used to actuate a throttle valve. And our program manager, Tim, came in and saw that our angle that we were reporting of our motor would count up the angle properly while it was rotating. And then once the motor stopped rotating, it would reset to 0. So we had to have a conversation with our guidance and navigation and control team, our program manager, Tim, within our own team, all about just, is that number supposed to reset to 0 or is it supposed to keep counting up?
Right.
And that's the thing about Avionics. It's like we were originally told it's supposed to reset to 0, but we realized, we actually need to just continue counting. And so we made that change, and that's what we do. We get our instructions, we do them.
Right. And I think if you've been watching, you might have seen that powwow happen in real time.
Possibly, yeah.
Yeah, it was a little bit stressful trying to convey and kind of get people to understand like our focus and position in terms of getting things troubleshot.
Yeah.
Because there's a lot of translating between mechanisms, like their way of thinking and our actual implementation of it. Because programming, I'm sure everyone knows, is a lot different than this kind of format where I'm having a conversation with you and understand it.
And especially in an environment like this where we're in a very high stress environment. I mean, we're dealing with high explosives.
And the heat too.
High heat,
Yeah.
high explosives, high stakes. All
Let's hope we rehearsed, and I'm so glad we have Tim. And he's
Tim,
actually-
I mean, why don't you come over?
yeah.
I gotta focus on this.
Okay.
We'll make an appearance real
Just a real quick cameo. You already know Tim. I mean, I think him and Adrian have been amazing in making sure that we get things and procedures done in a quick and concise, but also a steady and safe manner. Because that's what's most important is that
number one.
because if we make these high stress mistakes and we end up blowing something that should not have, been blown, or we done something that we should not have done, it's just a lot of work going down the drain. And I think they've done the best job they can to make sure that doesn't happen. Yeah.
100% on that.
Yeah. Any do you agree?
Yeah.
yeah.
Being great talk show.
Yeah.
No problem.
Hey, we got
That's
it.
the other thing about Avionics. We're great at talking.
now, man.
Oh, it's so funny you said that.
so funny.
We'll tell you about it later. But yeah. So that's what we're doing right now. Right now we're in pretty much the highest of stress.
Well, not quite the highest.
You don't think so?
No, because we're not in the red zone just yet.
Well, we're getting there. That's for sure. We're getting there. That's for
We're
sure.
close.
Yeah, I think that they are on standby to start loading. They're getting things prepared and such. You see Ben on camera with Cyrom right now, getting the GoPro set. We got to make sure we get you guys the best footage, which will be recorded actually, not live. I've just been told. Right?
Yeah. The footage that they're setting up for that camera, unfortunately, we were not able to pipe that in. You know, just that's the nature of things. We're moving, we're going, we're doing it live. Like you're seeing us right now. And so some things don't work out, and so we're gonna have to compromise. That one's only a recording, but obviously we're glad that we can bring a great live stream to you. And I mean, we're gonna have some great time, great footage.
Yeah, and just to toot our horn, I'm glad that Avionics got our things done so that we can actually bring you this live stream in a real professional setting, in my opinion. Professional.
Yeah.
I really love how it looks, honestly.
I'm you know that one of the biggest things that I think me and our whole team is really big on is work hard, play hard. So we worked real hard and we're playing real hard just to bring this to you.
Yeah, we're not playing right now.
I mean, it's work, but it's fun. You know, it's all that.
Yeah, regardless of how stressful and how important and how dangerous this all is, it's still a satisfying experience, and it's fun. Whether it's fun in the moment or not, it's still fun to be able to blow things up. I mean, we're not blowing it. But
Whoa. I don't know.
propulsing.
Yeah.
Yeah. And we're glad to be pretty much the nervous system of this rocket.
Yeah. I mean, yeah. Essentially, it's really Adrian, the test operation manager. I believe that's his title. Is that his title?
Can we have a formal?
Operations manager, yeah.
Oh,
Yep,
I got it right.
and
Look
we
at
got
that.
it. Ding, ding, ding.
Yeah, Adrian, the test operations manager, will tell me the data acquisition system test conductor. Excuse me. Sorry.
This is all a symphony in our eyes.
Yes. He will tell me the data acquisition system operator, man to open, and I will report back to him the digital readings of all the valves that we have. We do also, of course, have analog old-fashioned gauges up on the feed system, but due to the nature of our work, where there's a lot of heat going on over there, we're not able to read those off to you. So the data acquisition system is not only important for our whole team to know what's going on with our engine, but also to be able to actually command and control that engine.
And more importantly, take the next step in getting this project and keeping it moving, pretty much keeping the momentum moving.
Yeah, I mean, next steps after this are our team's looking at helping the guidance and navigations and controls team to start implementing code for making this into a fully propulsed rocket instead of just an engine sitting on a stand. And that's something we're looking forward to, an anxious anticipation. That's how I'll put it. So yeah, it's exciting. It's exciting.
I wasn't paying attention earlier. I was pretty much. I think you might have seen if you've been watching me on the testing landing. Did Ben already go through interview questions with you?
With me, no.
No. Okay. Well, will you tell us your major and what you've been working on?
Oh yeah, I guess I didn't introduce myself. Yeah, my name's Nathan Brown. I'm a fourth-year computer science major from Sacramento, and as I said earlier, I'm a part of the Avionics team. Primarily, my work has been with working with the data acquisition systems software side, most significantly with the graphical user interface that we are currently in development on to make my job as a data acquisition system operator a lot easier. And yeah, that's what I've been doing here.
Nice. Yeah, I've been working with Nathan for a long time, not only in avionics, but in our work career. So I know how hard he works, and I've seen him working hard on a lot of that data acquisition software. Just to interject real quick, I believe they're loading the nitrous. Say it again.
We're loading nitromethane right now.
Nitromethane right now. Oh my God.
Adrian, could you please help us? Because I genuinely have no idea what is nitromethane.
We're computer and electrical. We are not.
So nitromethane is our, if I can pitch in right here. Oh, look at that! I'm just in the perfect. Yeah, or whatever. So the nitromethane is our the liquid side of our liquid augmented solid rocket motor. As you may probably already know, we have a slow burning solid inside of our combustion chamber that is ignited with our little spark plug igniter. Once that's ignited, we will send in nitromethane to excite it. And so, yeah, we're currently loading that right now. There's a lot of things going on right now. So I got to get back to it, but thanks for pulling me in.
Yeah. Thank you for giving us some insight, because honestly, we are not aerospace.
We're not aerospace, but that's kind of the beauty, I think, of avionics. It's probably the farthest removed from the strict aerospace sides of things. But at the same time, we kind of have to know everything because we have to know like, oh, so we're gonna be building a printed circuit board to house some sensors, some inputs, things like that. Okay, what are those sensors? Why do they need to be there? So we can know like how much they need to be protected, what sorts of energy levels are they going to be producing, all kinds of things like that. And then we need to know how do we need to interpret that data? How do we want it represented? And some of those decisions are up to us. Most of them aren't, in terms of things like what sensors we want, where they need to be, maybe small adjustments in the space of like, oh, we can shift something like an inch to the left or an inch to the right. But for the most part, we're just kind of taking in, all right, we're going to need 5 relays, we're going to need 5 sensors, and they're going to range all these types of values. Go make that for me.
Right.
And then we do it.
Yeah, right. We don't really have the say so to when it comes to procurement. Procurement already kind of happened before, so we're kind of given these I would say components that I personally have never worked with before as the hardware side, and I have to make sense of them, make sure that they work together correctly, and make sure that they can fit together correctly on the PCB. So it is a very much a learning and a kind of a deep end kind of dive, because I would say at the beginning of this, I had no clue what most of the components on my PCB did until I started actually. Until I started working with RPL, I would say, and we joined about the same time, right?
Yeah, and I mean that's really the beauty of RPL and Cal Poly Pomona at large. Not to be a shill for our school, but I mean that learning by doing motto is not just a motto; it really is a philosophy, and we really are learning a lot by going out and doing all the things that we would do in industry, and it's really a cool thing.
And I do admit that at some point in my career, my academic career, I would say, I did roll my eyes at that motto. But but in all honesty, it's true. Like I don't think I learned nearly as much, studying the books than I have been in these short few months with RPL. And to RPL's horn, I mean, they have the capacity to work so closely together, work so quickly, and independently from a lot of the bureaucracy that kind of slows us down, which is always important in terms of safety and such. And I think that Tim and Adrian have been distilling that in a very, very easy to handle and very, very awesome way.
Yeah,
you know what I mean?
And that's one of the things that's really unique about RPL as a club from some of the other aerospace clubs in Cal Poly Pomona is our size. We are considerably a smaller team compared to some of the other projects on campus. But even though we have a smaller team, I wouldn't say that that's so much of a weakness, because it can enable some things to just have a higher level of collaboration, because there are just so many people that personally, and you see frequently where it's just like, oh, like I know exactly what you're working on. I have an idea that might be able to help you with this, and it's just kind of that environment that helps you like bounce things off of each other and come up with better solutions than what could just be had by just working in an insular group by yourself. And that's one thing that I've really enjoyed about working in this team for sure.
That's the best way to put it. The insular kind of barrier that some teams or some projects kind of it's not always intentional, but it's definitely significant. And never ever to take away from those teams. They're big for a reason, and they have big goals, big teams. It's just that we're doing something new, we're doing something different, and we're doing it in a cool way, like a very streamlined kind of way, I would say. Pretty much optimized. I mean, Avionics is a team of 3. I find that insane.
I mean, especially with our output. Like, it's incredible how much we're doing with just 3 guys.
Yeah. Sorry, guys. I mean, when you put Avionics in front of a camera, what else is gonna come out, right?
Magic. Oh. And I mean behind the camera too. Behind the camera, out of the scenes, we're just putting out magic there.
Yeah.
And I mean, speaking of behind the camera, quick shout out again to our media man, Ben.
Ben, come back into the camera.
Oh, don't fall down.
Dude, none of this would have been as beautiful as it is without Ben in the back seat.
Well, we can't just give it all to Ben. It was also Cyron for the background.
Yes. And that's like, again, another example of us working to get Cyron's mechanisms.
Yeah.
What does he have to do with media?
He was outreach before.
Oh, got it. See, that just proves how short we were here. But are we're still loading nitromethane? Yeah.
We think so.
Scary.
I think so.
Scary stuff.
It's gonna be interesting. It's gonna be interesting. I'm very excited.
Yeah.
Me personally, I'm very excited to be done.
Well, I mean, it's a bittersweet ending always. Always. You know what I mean?
I wouldn't call it bittersweet. I wouldn't say there's any negativity to being done for me because it's just like, wow, we finished that milestone. We're done with it. We're moving on to bigger and better things.
Yeah, I guess you're right. I just think I thought you meant like done with the project, never.
Oh.
Oh no. It's been an enjoyable journey so far.
Yeah. There's still more to do.
Yeah.
There's still more. We were writing code last night. We were writing code earlier today.
Oh my God, we were writing code on the live stream. If you saw a couple of us going back and forth, we just need to make sure that this calibration, we're triple checking and then triple checking one more time.
I mean,
Yeah.
it's just everything.
It's just the nature of it.
And I mean, even when we're not doing just strictly avionics related business, I know me and Yosh were.
Wait, were
Hmm?
they aimed at you and they still went up?
Oh, solid propellant is on its way. Oh.
Ooh,
We finished the.
big things are
nitromethane.
happening. Yeah.
We finished the nitromethane. We're moving on to solid propellant. Wow,
Yeah,
okay.
you probably can't. Yeah, they're not visible
we can
yet.
Zoom in a little bit, possibly.
They're not visible yet. Wow. Wow. That PPE is extremely necessary.
Oh yeah.
Jesus Christ. Never been a chem major. Never been a chem guy. So I can only. I'm out of my depth in that area.
Do you know the makeup of the engines team? Is it chemistry or aerospace or?
Aerospace?
It's
Purely aerospace? Mostly.
Mostly aerospace. Okay.
God. All of them. It's insane what aerospace majors are able to do outside of their field. What would you say that they? Yeah, come over here. Yeah, what? This guy, he's over here in the back.
This is our lead too.
Yeah. Now we have the full Avionics team. Come on, pull to the side a little.
Where are you sitting, Nathan?
Pull it to the side and then grab another chair. No, grab another chair.
I got it. Oh, it's all of us. Okay. Yeah.
Oh no.
Oh.
Ooh, hey, watch your language.
I didn't say anything.
I don't know if you had an interview already? No. How have you not had it? You're the lead. This guy. Well, yeah. Okay, good. Yash is always busy. He's just always busy.
Our whole team.
The amount of time we've stayed up at like 11 p.m., 2 a.m. Dude, it's brutal. But okay, so we might have given it away, but please introduce yourself, name, major, position. Go for it.
All right. Hello, my name is Yash Karwal, and I'm the avionics lead for RPL. I am a fourth year or fifth year aerospace major, or aerospace engineering major. Yes. And so yeah.
Yeah. And go ahead and tell us about your major contributions to this project, if you could.
All right. So I joined the team back over in late February, and I've been working on nonstop basically ever since for the data acquisition system that we're actually testing right now to define the characteristics of the engine. So everything from all the sensors, all the actuators, so our solenoids, our motor, all of the circuitry for it, and to get all the data from 300 feet away, about or so, from out there to in here through an Ethernet cable, and logging all the information so that we can view it later on. So that's kind of my main job at the moment. Later on, once we get the actual engine characteristics and we know that it can be closed loop controlled, we're gonna do the flight hardware. So our lander's gonna actually start flying, hopefully. That's our plan, right, guys?
Hey man, you're the lead. You're the lead.
He's the lead, whatever he says. Like I said, the central nervous system, and we're gonna make sure that stays or keeps, I should say, our systems or everything going. The process.
If data is blood, then we're the heart.
Do you like that analogy better? Okay. All right. No, we're not giving a podcast. Actually, I'm gonna give it back. Ben, do you want to continue the interview? I don't have your questions. I don't have your. Come on. Charisma. Did you already interview Cyron?
Nah, yeah, we were
Okay,
about to.
he's on.
All right, we can do double. It's been. All right.
That was the Indian duo.
I feel a little left out here. Oh, shit. All right.
I'm a little sleepy.
Are you okay? You need a Celsius? Yeah, we got the AC on. It's getting a little.
Actually, low key.
I think I think we took off. I'm just saying it, you know.
Huh? Give it back.
All right, you heard plenty from our avionics team. Great talk with them. Great talk. Now we got 2 members. You guys want to introduce yourself?
He's still avionics team.
Yeah.
You can go from
Yeah.
the left.
All right, I'll reintroduce myself again, I guess. So my name's Yash Karwal, and I am the avionics lead, and I'm a 4th year or 5th year aerospace engineering major.
What's up, guys? My name is Sairam. I'm a 4th year mechanical engineering major, and I am RPL's mechanisms lead.
Very impressive roles, you two. It's crazy. Let me get my handy dandy questions out for you guys. You know what I'm saying? Shoot, it's day 1, man. By day 2. Yeah, exactly. You know, I've been putting in the work right now.
We're out here doing this shit impromptu.
Shoot.
On the fly.
All right, I don't need the phone anymore. It's just a little review, some notes.
Okay.
All right, so how did you guys sleep last night? Where did you guys sleep? How many hours did you get?
What's good? What's sleep? I mean, we slept at the hotel nearby, Best Western. Slept for a good maybe 2 hours. It's pretty good sleep. Yeah.
I slept in my car out back with, I think, Samuel. I think he's earlier here, so he slept in my car as well. Just folded the seats down and then just slept for, I would actually say about 4 hours, which is pretty good. And then I completely skipped on, to the side. Okay, excuse me, I gotta leave. I'll be back.
All right, I guess avionics is leaving.
Yeah. Unlucky, we lost one of our interviewees. And I was about to say, that's the most sleep I've heard today.
I know.
4 hours? That's crazy. You know, we get sleep out here. We get our shut eye. All right, Sairam, next question.
I know they're watching on the TV.
All right. Oh, okay. All right, what have you been preparing lately? What have you been working on in preparation for this hot fire, Sairam?
So I'm working closely with our guidance, navigations, and controls team, as well as our avionics team, to actuate our motor in a way that can control our valve. And since one of our goals is to throttle today, they have a sequence where they try to open and close the valve in a certain sense. They try to go from 100 to 40%. Or, yeah, I might be wrong on that. Actually, don't quote me on that. And essentially, what I made was the physical structure on how we control both that motor and the valve. And in addition, we have an external encoder that we are using to collect data to map our position. And I also created the structure to actuate that encoder with our motor. Pretty cool stuff. It's basically just like, instead of when you open a door handle, right? Or no, when you open a valve for anything, right? Let's say you're opening up a faucet, right? Or like a spigot. Instead of my hand opening the spigot, we made something to open the spigot for us.
Very nice, Sairam. Great to hear. Sounds like you've had a lot of work on your plate lately,
Yeah.
Tough deadlines, you know what I'm saying?
Pretty tight
Yeah.
deadlines.
Sairam, do you work out?
Do I work out?
Do you work out?
What a good question.
That polo looks pretty tight on your arms there. You might have to go up a size.
Then I might do. Yes, I do work out. Yeah, I try to work out as much as I can. Obviously, the deadlines here have been setting me back a little bit, but consistently, I used to go every day. I haven't gone every day for the past few weeks, but it's all good. We'll get back on track. And yeah, I do work out.
Very cool, Sairam. You're looking very big.
Thank you, Ben.
Yeah, I just had to say that. Put that out in the world right now.
Question.
Oh,
Yeah.
Oh, it's really important. Do you work out, Ben?
nah, not really. I'm not about that life. That's kind of, I'm busy, yeah, business major and all that, a lot of coloring in the lines, my times tables, Last time I got 12 times 12 down, 144, baby. If my professors are listening, I got you.
You did get that.
Yeah. All right, next question, Sairam. I'm a little, it's my first interview back in a while. All right, Sairam, how long have you been in RPL for?
I've been in RPL for a while. I've been in RPL since my sophomore year, first semester. So now that it's my 4th year, first semester, I've been in for 1, 2, 3, 4. I think about 4 or 5 semesters. Yeah, been around for a minute.
Very nice. And what would you say is your favorite memory from all these semesters you've been in RPL?
Definitely, my favorite was our second Hotfire. It was very, very exciting. We were kind of already under pressure since we didn't really successfully go through our first one. And so we had a lot of excitement, a lot of things going on. Back then, I wasn't doing mechanisms. Mechanisms is a new team. I was actually doing what Ben is doing. I was the one who was doing that live stream, and many things went awry. Many things went wrong. And we got Ben in to fix everything, and he's doing a pretty good job.
What can I say? What can I say? With the plenty of help from Sirom too, of course, of course. All right. What are you trying to achieve with this hot fire personally? We know the goals of the whole team, but what are you just personally trying to go for with this?
I think I'm just trying to establish a good environment with my team. We're a very new team. We were established basically this summer, and me and my crew out here, we've only really known each other for not a very long time. And so trying to boost our teamwork skills is probably my main goal. Obviously, my technical primary goal is to make sure that our spigot, right, our valve is actually getting actuated. And so that's my main technical goal. And honestly, if that doesn't happen, probably gonna be pretty sad because we put in a lot of time and a lot of work into getting that work. But yeah, also I brought my 3D printer in here just in case something broke, so that's kind of fun. We've been printing stuff, doing replacement just in case things break. So that's cool too.
That is very cool, I must say, Siron. All right, you got through all the tough questions. Last question for you. Actually, this might be the toughest one of them all. Would you rather have unlimited bacon but no games, or games? Unlimited games but no games.
I gotta say, I'm vegetarian, right? So unlimited bacon ain't gonna do much for me. I'm not gonna lie. I could sell it and make a lot of money, but then unlimited games, but no games. That just speaks to me in a certain way, right? I introspect what that means. That just means unlimited games, but no games.
Yeah.
Does it sound exciting to you? I
Mm-hmm.
think it sounds very exciting.
It's unlimited games.
Yeah,
What can you
but no
say?
games. Don't forget that part.
Yeah, yeah,
Don't,
true. You can't forget the no games.
You can't forget the no games.
But
You
it
get
is
unlimited
games,
games though, yeah.
unlimited games.
Unlimited games. So yeah, that's probably what I do.
Very nice. Siron, what's your opinion on?
Huh?
What's your opinion on? How do you feel about?
The way I feel about it's pretty cool.
Thank you very much, Siron. It's been a pleasure to have you on the interview. Thank you very much.
Where'd you get it?
That's confidential. I can't say, if you know, you know. That's what I'm saying.
Man, are you single?
Maybe. Are you single, Siron?
Possibly.
All right. Well, CPP.RPL on Instagram, you know what I'm saying? You can see Siron in person. Maybe he's tagged there, So, yeah, thank you very much, Siron. And, yeah, keep up the hard work. Appreciate it.
Say that again, Yash. How are the PTs reading? Focus on that. Yep.
Yeah, it's not going through. It's on. Oh, I was expecting a tone. PT1 reading nominal, PT2 reading nominal, PT3 offset at about 8, PT4 offset at about -2, PT5 reading 0.
Copy. The load cell?
Load cell currently fluctuating, up, stabilizing at -50, was at 25, fluctuating heavily, stabilizing closer to 25 negative right now.
What about now?
Stabilizing at around -50.
Okay. Kind of read, like, as because they're tightening around the engine. I want to see what it's doing.
Definitely fluctuating.
Yeah, I'm reading fluctuations. Looks nominal for doing mechanical work on the load cell.
Sounds good.
But this is a conversation you and I will be having. You're up.
Because the regulator there, I don't know exactly how it works. Last time we had like a valve regulator where we can just grease it and it would like don't decrease pressure there. But that one is like just a handle on the tank itself. And I'm not sure if that like I'm not sure if it depressurize it just for that.
Okay. Were you able to like pressurize and depressurize with that tank?
I mean, I'm not good. I'm just,
Would you be able to just know how to close it?
I mean, I know how to open and close it. I just don't know if it, like,
We only just need to close it.
okay, because there's still gonna be pressure in the line between the nitrogen tank
And the feed system.
Yeah.
That little second.
I don't know. I don't like pictures.
once the pressure gets lower to a
Well, you just did
That's
30
engineer 1 at
seconds.
command. We're basically on 4.5.5.
hold on. So I think though, I mean,
Say copy.
this
Copy
is fine.
that.
0.6.5.
I think this is fine here.
4.6.5 readback.
So close MV1, CO2, CO1 is closed, CO2 is closed, MV1 is closed. I think this is fine. So I think we need to freestyle at this point because depending on what the pressure is like in the lines between manual ball valve 1 and regulator 1, manual ball valve 1.
Could I please get a readback on that last communication that it was 4.6.5 and not 4.5.5? Okay.
So these are going to be the steps I'm going to relay to you.
Well, that's what I'm saying. What we might need to determine how it is. Everything past hand regulator 1 is going to be depressurized. Everything from here though, this is going to be at a higher pressure because anything above hand regulator 1, manual ball valve 1, into the engine tank,
It's just going to be
depending on what the nitrogen tank over there does, it might still be pressurized, and depending on the pressure inside of it, I might need to figure out how to do that if it doesn't depressurize it from closing the regulator itself. Because what we could do is I could close the nitrogen tank, leave MBV01 open, then
Attitude test control. The app plate is secured on. We're going to clear to allow for launch.
so I go from
Confirm.
We copy.
this here, I leave MBV01 open.
Dude. Tommy's watching it, and he just said he was watching it, and he said someone just threw a
leave
wrench to
open,
another
then this-
person on camera.
This goes into
Are we? Oh, we're.
to open vent here.
We'll just remind our team not to do that.
Then when that's depressurized again,
Oh yeah, to get that little bit of pressure out, and then
Just a reminder that we're live.
30 seconds. All right.
Was it 4.5 or 4.6? I guess if you have to have the door closed, I guess. Was it 4.5 or 4.6.5? For the test item finish. Okay.
I'm sorry. You're long body. Can you hear that one more time?
Oh, that's for these guys over here.
Ben? Oh, you did it now?
ladies and gentlemen, we're really in it now. And by in it, I mean we're moving into test procedure, are we not? Yeah, we're moving into test procedure. So what that means is we're going to be following all of the steps that we've written down, all the steps that we've rehearsed, literally at minimum 3 times, but more like probably 6 total because we rehearse in our individual teams and then all together as one big unit. And yeah, you're speaking right now with your data acquisition system operator Nathan Brown. I'm currently eyes are actually trained on the pressure transducer, load cell, solenoid readout. I actually can't see the test stand from where I am, but that's important that I can just read all of these values, and I'm watching them very closely. We're keeping our values nominal. All of our in a second, these values will change. That is true. We are going to be moving towards pressurization very quickly. And you will be hearing me calling out these values to our test coordinator? Conductor. I'll get it one day. And, you know, if you hear me in a panicked voice, we might have some panic, but that's probably just me making sure that we get all these values coming in because our test conductor will have a lot of communication from all sorts of people. Let me go around the table here. Over to my left, we got Ezekiel Zizo.
Yeah. We're acquainted. Just wanted to let you guys know the rockets you saw. I think we were trained on which rocket?
We were trained on a liquid oxygen rocket, I believe. Is that correct?
Trained on?
Yeah.
Oh, yeah. Yeah, that was a lot. Basically using cryogenic fuels. It was a liquid fuel rocket, so it has a really high impulse or really like large force it uses. So it went pretty high. I think both of them that you saw. Oh, one of them you guys didn't see because we were trained on the wrong rocket. But yeah, they both are pretty powerful rockets.
Yeah, that was pretty embarrassing. we had multiple rockets going off at once, so I guess we got miscommunication, and we were focused on the wrong one. But oh, nice, we're getting some. Nice. Good. We should be getting a weird reading from PT 4 or 5, right? Because they're gonna be lining up the.
Be atmospheric still.
Still atmospheric. That makes sense. Yeah.
Nothing's happening right now.
Right. Okay.
I am seeing a trend on PT3 closer to 7 occasionally, but that's still within nominal values.
Yeah.
Just slightly more often, but that's
AC going a little off.
Yeah. Fix that after we could record the data.
Just know mentally 5 to 10 psi. It will increase.
Yeah, we have a.
our air is 2 psi whole.
About.
Yeah.
I'd say 5, give or take.
Yeah.
But it's like to be on the safe side.
So a low enough error to actually continue with the operation, the procedure, and all that.
Yeah, 5%.
5% is well and within, I think, normal, plus or minus.
Yeah. I mean, it's normal. We're looking at it. I'm getting very, very familiar with these values in front of me. But very soon they will be changing very rapidly in front of me. So
They'll be changing in front of your guys' eyes because, dude, static fire is right around the corner. Like we have just a couple more steps.
just a couple more minutes. Within the hour, I believe.
So if you know anyone who's interested in this static fire, the success of our static fire, which will be happening soon.
Yeah.
Make sure to tag them, bring them into the live stream.
Pad, just confirm. Do you guys have a copy of the test procedure?
Always important.
Copy that. We can send one over to you.
I got you.
Test procedures are over there.
And you may or may not heard that short little exchange over here on the broadcast, but we were just confirming that our members over at the testing pad have a physical copy of the testing procedure. Obviously,
Anybody in the shade?
obviously, our team is highly trained and we have really studied these procedures and we really do know them like the back of our hands. But things evolve, things can change even on the day of. So we're making sure that everybody has a copy to have a common reference off of at least. It's currently 3:02 p.m. here in Randsburg, California. We're at the Friends of Amateur Rocketry site, and you're listening to Cal Poly Pomona Rocket Powered Landers Project's live stream of our third static Hotfire Test. Right now, you're speaking with Nathan Brown, data acquisitions operator, Over to my right is Adrian Bermudez. Just a second ago, we had Ezekiel Zizo on my left, and further to my left, we have our lead avionics manager, Yash Karwal. We're really coming down to the wire, folks. Like Zeke was saying earlier, Ezekiel, if you know somebody who is interested in this, now would be the time to call them in. Ben's not in here. And just to give you a little bit of a play-by-play here, we're looking at the data acquisition screen, and right now we're seeing our load cell values fluctuate about 0 to 20 pounds of difference. That's completely normal. Right now, we're currently wrenching on our engine, as you can see on your screens, and on my screen right in front of me, we're seeing a difference going from about negative 80 pounds to about negative 60 pounds of pressure on our load cell reading. And so that difference in load cell pressure is just an indication of different springs being tightened or loosened within our test engine.
Status? Can you give status on pad?
Yeah, they're screwing on the half plate.
Are they working on the pressure transducers as well?
1 second.
Copy.
It was misaligned.
Misaligned, copy.
And yeah, we're just double checking in with our members at the pad here. We've got our test conductor, Adrian Bermudez, keeping an eye in the sky, not literally in the sky. He's actually about 300 feet away on the ground on our test pad, overseeing our whole operations here. Just over to my left, we had Sairam Sakrant enter one of our Shrikant, excuse me. Shrikant enter one of our mechanism systems members. Sairam, how you going and feeling into this?
Actually, a lead, Nathan. Isn't that crazy?
I mean, excuse me.
Yeah, I'm just kidding. I'm just kidding. We're chilling, you know. 1 sec.
Apparently so.
All right. Yeah, we're just trying to install our aft plate and get our PTs installed, our pressure transducers installed. And we're kind of at the home stretch, guys. You know, we're gonna be firing. I've been told in the next half an hour. So, you know, don't take my word for it though. Don't shoot the messenger if that doesn't happen, because you know every single time we say a time, that usually doesn't happen. But you know, knock on wood, that's probably gonna be about 30 minutes, guys. Anyway, I'm gonna pass it back to Nathan.
Yeah, I mean that's just the nature of rocketry. Things can change in a moment's notice for the better or for the worse, and we're always making sure that we're having things change for the better, even if that is a delay in our rocketry procedure. That really is we see that as a change for the better, because that just means that we're being more conscious of our safety and making sure that everybody's being completely safe here. Checking back in with the status of the data acquisition system once again. We're still reading nominal values across all of our pressure transducers, and our load cell is actually increased in force exerted. So we're now at negative 60 pounds, and that's just an indication of the changes that the team is currently making to the engine, which is still within nominal values we expect to be about here. And you know, coming in at a nice 90 degrees here in Randsburg, we've got some scattered clouds to the west, or southwest, excuse me, kind of a bit over to the mountain pass there, going towards Edwards Air Force Base, and we've got clear skies in every other direction. It's a beautiful day out here. You know, even with the 90 degrees, we're lucky to be currently transmitting to you from one of our bunkers here at the Friends of Amateur Rocketry site. And yeah, we're gonna have a great test today, guys. And we're all really looking forward to it. We're all really looking forward to it. Be like I have to grab the keyboard, so it's a whole thing. It's fine. It's fine. Maybe Ben can. It's hot, but it's not that hot.
Okay.
So just make sure you finish them on.
Wait, let me turn
Before they're
on.
done, yeah.
Let me turn
Or
the
hot.
stream, see if
Just
it's
finish it
good.
before you come to
Wow.
Oh, my fault. My fault. My fault. Didn't pick up on that. So they've already seen it. Oh, hilarious. Wait, what'd your sister say? Oh, so interesting. Megan does sound pretty cool.
I would say so.
Yeah.
very, very smooth.
Very smooth.
Smooth operator.
Control copy. We got it. Can you remind Ben to put the camera on our IV? Camera is on the IV. On.
And ladies and gentlemen, just for a bit more information, currently here in our broadcast slash control booth, but mainly our control booth. And right now we're about to have our structures lead here, Cyrom. He's currently, you know, we shouldn't have gotten me to broadcast this. My mind's in a million places. So we have Cyrom currently putting aluminum foil all over our GoPro for our wide angle view to make sure that we are protecting it from heat. And we have currently realigned our main camera to better represent our test situation.
Cal Poly innovation that can excite anyone. We need to make sure that our stuff keeps. What is what is what is the where are we at right now in state? Currently screwing on the afterplate, and that's important for
So we're currently screwing on the aft plate and making sure that our pressure transducer, which is new to our engine, we are having a new pressure transducer reading the chamber pressure, so that way we can have that value for us later in our calculations. But right now we're screwing in this aft plate so that way the solid propellant is fully enclosed inside. And once all that's inside, we can move on to our test procedure where we will begin pressurizing our liquid propellant and getting ready to have some fun.
Yeah, and you just touched on it. I think that's I don't know if we ever touched on that. It's a solid augmented liquid augmented solid rocket lit engine motor. All of the above. What's up? Exciting stuff. We're getting more protection for our other camera equipment. Like I said, stay tuned. Later on, we're gonna actually upload the recording area. Yes. Oh yes, we're capoling. Yes. Sorry to mute like that, guys. We had to discuss some logistics. We'll be posting a reminder soon, but just to let you guys know, those who are still watching, we are so close, minutes away. In fact, we were told to set a reminder or a notification that we should be 10 minutes away from our static fire. So stay tuned, and we'll keep you guys updated.
confirm right now, so.
Well, yeah.
Yeah.
I'm just updating you on what.
For sure.
Keeping everybody in the loop.
We have an extra PT.
We do. Is it soldered?
We have a solder in there.
Okay.
I guess I'll go start on that with inventory.
Is inventory an idle?
Wait. Yeah. As long as one person here.
I will be here and I will monitor this.
Yeah, a lot of people are in the third now.
I'm pretty confident we'll get through that, but just a caution. And Sairam and Yash are already going to verify everything else. They're coming back right now. Oh. That's a shitty angle.
Oh yeah, that one.
Zach, what PT5 reading right now?
Currently reading PT1, PT2, PT3, no read on PT5.
What about 4?
PT4 has nominal pressure reading.
Is this ignition setup basically?
I think for the initial. What?
This is what needs to be. Like, is this already done?
The procedure is where we put it onto the solid and then they can hook it up to the box, and the box is right here.
And the box is wireless, right?
Mm-hmm.
Alright, that's sick.
Yeah.
Okay. Well, if they're that close, I think now I'm gonna use the restroom.
Change. Did it change, Jack?
Currently reading on PT1, PT2, PT3, PT4, PT5.
Big nominal?
PT5 is not reading. All other PTs are reading nominal.
PT5, is it reading or not?
PT5 is not reading.
Is there any way we can change the live stream to say estimated hot fire time 4 p.m.?
Sure.
Had to inventory. Can we get 2 bolts that are either half-inch 9/16 or somewhere around that range that has matching non-lock nuts with it? Daniel's on his way to come grab those and help out. Can you repeat the size, please? Half-inch or 9/16, or 5/8. One of those 3 with matching non-lock nuts.
PST.
PST, you're so right.
Daniel can help you look.
Alright. How's that looking good?
Yep.
Oh,
Looks good.
nice. I'm gonna go take some pics.
Sounds good.
Inventory, do we have a multimeter? We should have a multimeter. We'll check right now. confirm that. 2B. Yeah.
Yeah, it's hot in here. So stand right here.
Somehow that's perfectly cropped off of not the stream.
Alright, I'll be back.
Ladies and gentlemen, this is your data acquisitions operator, Nathan Brown, speaking with you once again. Just shortly to let you know, we're going to be shutting down the main camera here for just a second to let us cool down. We're actually fighting heat on all fronts, personally and with our hardware, and to just preserve the integrity of our hardware, including our broadcast equipment. We're going to short down the main camera view for just a second. But if you would direct your eyes to our beautiful internal view of our control room, to give you something to look at, as well as the wide angle view that we will have on the lower right of your screen. Ladies and gentlemen, it is Nathan Brown here once again, your DAC operator, that is data acquisitions operator. We did just power down our main data acquisition system. I know, very sad for fans of data acquisition, but actually, we will see that as a good thing. We will see the fruits of our labor coming about in just a second. As I said earlier, we are fighting heat here in the broadcast booth as well as on the pad. So we are turning off the power for our systems to try and give them an opportunity to cool down and get a little bit more air circulating through them. And we'll get powered back up here in a second. In fact, we should be able to power up the main camera in a few minutes here just to give you a better picture of the live stream. Once again, ladies and gentlemen, we are anxiously awaiting the eminent static hot fire of Cal Poly Pomona's rocket powered launcher project. The goal of this specific test that we will be conducting today is to demonstrate that we can use our liquid augmented solid rocket motor to, in essence, throttle the output of the solid propellant, achieving one of the goals of the CPLC, that is CPLC. Um, can't find the website for it right at this moment, but that is a competition between a lot of different collegiate rocketry programs that we are currently competing in for a numerous cash prizes for numerous objectives, hopefully culminating in the final hop of a lander. Ladies and gentlemen, happy to report that at least in our broadcast booth, we have somewhat beat the heat, although an interesting update has just occurred. We did have the AC units running in our command center / broadcast booth space, but we are currently turning those off in order to conserve the power. Interesting fact about the Friends of Amateur Rocketry site is that they have to generate all of their own power, pull all of their own water, dump all of their own sewage. So it's a completely self-contained operation here. And oh, excuse me, we just had a bit of a squib fire on one of the smaller rockets being launched off by one of the Boy Scout troops in attendance here today, Troop 164, I believe. Anyway, as I was saying, yeah, the far side is a fully self-contained site, generates all its own power, pumps its own water, dumps its own sewage. So, just in an effort to conserve that power, we have turned off of the AC units inside of our control booth, and we'll just be switching back to the old-fashioned way: windows and doors open. No windows, just doors. But we are glad to say that our broadcast equipment is currently surviving in the heat very well after a quick 5-minute break, and we will be resuming operations of our data acquisition system very shortly.
Not much. It's a little bit. Leave it all. We have one small one. I want all of it.
Wow.
Jimmy? What? I already find the far guy. Bring him over here. Who? Alright, never mind. Matthew, go run. For our igniter? They gave us permission to hook it up. Going to turn the jack back on. Josh, did you say turn the DAC back on? I'm going to turn the main power of the DAC back on. Copy. Can someone press state 5? Do we have the key box in the control room? We do not have the key box in the control room. Adrian, you need to find the far guy and get that key box in the control room or the bunker. You find where that key box is. I thought that was taken care of earlier. Okay. Are we ready to do that? Are we ready for igniter box? Tim, do you copy? Repeat. Are we ready for the igniter box at all, or? Correct. The igniter box that is at the pad is here. We need the key box that wirelessly connects to this box. Copy that.
Check one. And ladies and gentlemen, we are successfully back. We have overcome our heat challenges as well as many other challenges that we were troubleshooting, including internet connectivity. I do apologize for the lapse in our stream, but we are encroaching on our testing eminently in about 5 to 10 minutes. We have restarted our data acquisition systems. We have made sure that all of our broadcasting gear is good. We have cleared our canopy from the testing site as well as the ladders, and we are starting to move into the red zone. Very, very soon, we will be seeing our engine, our rocket motor, our liquid augmented solid rocket motor. We will be testing it. And we're hoping to put on a very good show for us as well as the CPLC, the competition that we are competing in. One of the main reasons that we're doing this live stream is not only to document and show for the public's sake, but also to prove to the CPLC that we have achieved our various goals of their competition. And we So we have currently attached the igniter into the rocket motor, and we are eminently preparing to launch this rocket. We are now waiting to receive the remote igniter box into the control room, and we will be able to go ahead and get our rocket motor started. Right now, we are going to have some of our And so we are going to be waiting to receive that igniter box as well as possibly do a remote continuity check of our system.
Man, it's so hot out here, and it's about to get hotter. We're about to put some heat in the air. Give us a couple, but y'all are seeing everything we're seeing, so y'all know. How you feel?
I'm feeling good. Good. Feeling ready. Need to
Keep doing that. I keep doing the exact same thing. Keeps making the exact same mistake. Okay, let me come around you. Well, hopeful as well, but I gotta say, everything in every other regard, that makes one of us. I'm exhausted. I'm tired. I'm hot, but we persevere. That's what we're doing right now. Beating overcoming odds, uh, troubleshooting to the best of our ability, and succeeding, I might add, since we are ready to test.
Yeah, especially for such a remote location, as I was mentioning earlier, we've really demonstrated a great ability to troubleshoot through nearly any problem that has come our way, and successfully get this engine ready to fire. Checking back in with our data acquisition statistics, we're reading nominal values across all of our PTs, and we are reading a nominal value as well on our load cell. All of the vents are currently closed. And yeah, that's the current state of affairs here. We've been running our data acquisition systems for about just about 7 minutes here, I believe. That's the not sure. Yeah. Yeah, you may not be able to hear it on the live stream there, but we are currently having our test ready signal bullhorn being played, and we are firmly moving into the red zone. Or step. Somebody already ready. I just don't have. Yes, I'm ready to start pressurization. SVO 1, 2, pneumatic ball valve 1, and manual ball valve 3 are closed. Confirm. Radio check clear. Cal, manual ball valve 3 is closed. Press. Okay, we hear you. Skipping through to everything is closed in ambient. All pressures are closed in ambient. Kyle, everything is closed in ambient on your side. And regulator 1's closed. Yep. Yep. Confirm. They're closed. All manual ball valves and hand regulators are closed. PVO1 is closed. Confirm. You're opening nitrogen bottles? Kyle, slow down. We're at stage 5, yes? Copy that.
Go to 5.05.
We are both at 5.05.
Sorry, 5.04.
I copy, I copy. Shh. Please, please. You're at 5.05 now? Kyle, where are we at?
Fully open to 5.05.
Okay. Is it open? 450 PSI, Kyle.
Do it 4 or 5.
Never mind, Kyle. 550.
Pressure on HR01, 550. I've got the increment.
And then go ahead and open manual ball valve 3 to fully open once that's 550.
Clear. Wait, there's no more manual ball valve 1. I have to open MBVO3.
That's fine, that's fine. Copy. Very good. 5.08. Not sure if you want to do that one. You already did that? Copy that. Okay.
No, how do I?
Oh. You already have, right?
Yep.
We already have continuity, Kyle. So you're fully okay to evacuate test stand.
No, out of here.
Okay.
Woo! Okay.
I
You
need-
know the ignition procedure, Nathan? You've
Breathe in 8?
Yep.
Not yet.
3 to open. No, not yeah. Obviously not yet.
Okay, ready? Okay. Where's Kyle?
And this is when you
Where's
see
Kyle?
smoke confirmed from.
Okay. We're gonna open SPO1, okay? Okay, go ahead and fully open SPO1. Ready, 1?
Probably, yeah. Nope.
No.
Should we wait? Hold it. Yeah,
Probably.
So go for. Okay. So
We'll open S. Surprise? Yes. No.
wait.
Okay.
Are we? Yes.
Go ahead. Open SPO1. Go ahead. Ready, 1. On your mark. Mark.
let it pressurize. Can you communicate to me in 10 psi? Okay, just read PT1, PT2 slowly. Okay. How's PT3? Just tell me when you're settled. Okay. And then where's PT3? Somebody give me time. Want us to hold here? Okay, I'm gonna hold here. All right, holding here. Again.
11:45 in the data acquisition we are holding at that time.
Okay. Oh. Somebody let him know. Go. Pressurize. Sorry. I
Oh, hey, you're
On. You're gonna at 5 count.
yeah. Hey, go. Okay.
I'll do 5.
Ready? Only when Adrian says go for smoke. Adrian, you ready?
Go for sleep, right?
Yep. Go.
Are we going?
Okay.
Just press that button.
Hold. 3-8. 3-8.
Oh my gosh. What's the load? What's the load?
Load is at 125, 130, holding at 135 steady. Load at 140 steady. Load climbing to 150. PT1 and PT2 485, PT3 100, PT4 50 and falling. PT3 falling slowly. PT1 and PT2 holding at 485. Load at 150. Flame out at 12,900.
Somebody verify when nitromethane burnout's out.
PT's dead. He's dead. Dead.
No, we still have PT values coming in.
All right. Okay. Let's see how long you monitor for.
PT4 is
We want to burn. We want to throw it out. We want to throw it out. Wait until
load
we-
cell still at 20 pounds.
PT4 dead. PT4 is dead.
PT4 is at negative 40.
No, it's dead. It's dead. Pressure is at 400.
485 holding.
Sorry. We have P1, the pressure above that tank is 480. P2 480. I believe close to valve.
Confirm close on solenoid void valve. Solenoid valve closed.
Yep. We let it.
Just let it flow out first.
Yes, it's closed.
Are you able to schematic valve out?
If that is PT3, yeah. Or if that is number 3, yeah.
Yeah.
TBO V1?
That
Yeah, I mean.
PT1, PT2 at 370 and falling.
Want to close PPP01?
Yep.
Go ahead and close it. Close it.
PT1.
Can you close TV.
It worked.
Close valve.
Close.
And then it's closed. Okay, we're gonna wait. No drips. Any drips?
No, we're good on nitromethane.
Okay, you. Okay.
Nitromethane.
Open SVO2 to vent.
Vent.
Confirm vent.
Venting.
SVO2 open. Open. Okay.
PT
Falling. Good.
85.
Tell me when you're zero. When you're gonna have to relay it to him.
PT1 is 215. PT2 is 220. PT1 170. PT2 175.
Okay. We're almost. Okay. We're almost there. Almost there. Good. Split event.
Oh.
Whoa! No, the canopy! Oh, thank God. Read me values.
PT1 65. PT2 70.
Thank you.
The
45 and 48. Dropping. These will be reading about.
load cell 15 positive. PT1 25. PT2 28. PT1 20. PT2 23. PT1 15. PT2 17. PT1 10. PT2 13.
What are we?
PT1 8. PT2 10. PT3 7. PT1 5. PT2 6. PT3. Oh, sorry. PT1 3. PT2 4. PT3 7. It's pretty close to atmospheric there. Well, folks, I mean, we should probably get Tim to talk in here if we can for a hot second. Just a little bit, possibly. Yeah, let's go ahead and do that. Where's that pointing? Oh, there it is. Like that. Transition. Oh, hold on. Oh, that's the wrong GoPro. Whatever. We'll just. I know that I don't know why that camera's not. Oh, wait a minute. That's
Uh,
there. Oh, it's all the same camera.
yeah, I'll-
There we go. Now we can figure out life. Think about life for a hot second. I think this is literally the hot seat 'cause it's in the sun.
yeah.
I mean I'll sit down here. Ooh,
Very funny.
wow, that is. And I mean, not a moment too soon because the sun was in my eyes reading those values off.
Yeah.
One of our PTs were destroyed in the testing process. Thank you, Zeke. And we're having Yash currently work on reading off pressure values to the pad. So yeah, the tests pretty much went as planned. Actually, there was a little minor thing, but it's something we completely expected and practiced for. One of the buttons didn't send the command, but our code is coded in such a way that that's actually not an issue. We press it again and it'll work just fine. That was a little nerve wracking, but we got through it, chilling. And I think some celebration after a bit more hard work and preparation for tomorrow will be in order. But you know, that's how it is in RPL. There's a little bit of play, but there's a lot of hard work. So yeah.
Yeah, so I think we'll wrap it up here. We're gonna go home, get some R&R, celebrate a little bit, and then we'll be back tomorrow. So yeah, I'd say overall some success, maybe some things to work on, but I'd say overall, from my standpoint, it looked pretty good. So no complaints from me. Yeah, you got anything else to say, or should we wrap up the live stream?
Just thank you everybody for watching. Tell your friends we made a successful throttleable hot fire, and yeah.
Exactly what he said, and we'll be back tomorrow. So